So today we are moving on in chapter 19 to section 2. So on Tuesday we looked at multiplication of numbers with exponents. That means we added them, and division means when we divide, we are subtracting these exponents. But today we're looking at when we have negative and zero powers as exponents. So our learning target today is we are going to understand what is meant by negative and zero powers. And when you see the word negative, I want you to think of the word flip. This will make more sense as we go through the lesson. But if you can remember the word flip, anytime you see a negative exponent, it will be beneficial. With zero powers, this is nice and easy. Say if we have 7 to the zero power, anything to the zero power is equal to 1. So say if we had x to the zero power, that is equal to 1. Now, where it can get a little different is, say, if we have more than just one base. Say if we have 7x to the 0 and then y. So x to the 0 would be 1, but then everything else stays the same. So we'd still have 7 and y, so it'd be 7y. So that is the only difference there. So make sure that anything time you see something being multiplied by 0, then that means it is equal to 1. Okay, so moving forward, we have a table here again with expanded form. We've seen this on both Tuesday and Wednesday. It is the same pattern, but we're used to seeing that there's a larger exponent in the numerator compared to the denominator, but now that's different. As you can see, we have 2 to the 5th power in the numerator, so 2 times itself 5 times. And then in the denominator, we have 2 to the 8th power, which is 2 times itself 8 times. And again, it's the same process of where we can begin simplifying. So since there's a 2, and that is 5 different times, and we're able to cross out, 5 times. And then after we cross out 5 of them in the denominator, you can see that we still have 3 remaining. And when that is an expanded form, we know 2 times itself 3 times is 2 cubed. But since that is in the bottom, that means that you need to leave it in the bottom. So we would have 1 up top divided by 2 to the 3rd power. And we did learn yesterday when we're dividing with exponents that we separate this, that we leave the same base, but then we do the numerator exponent subtracted by the denominator exponent like shown here. And that is where we get 2 to the negative 3. But anytime we see a negative in the exponent, that is why we change it or flip it and make it 1 over 2/3, or 2 cubed, sorry. So continue on to the next one. I'll write this one out in expanded form again. So we get 5 cubed in the numerator. Blue. So 5 times itself 3 times. And then we have 5 to the 6th power in the denominator. So that means 5 times itself 6 times. 2, 3, 4, 5, and 6. Again, we get to simplify. So anywhere you see that there's 5s in both the numerator and denominator. And for this one, again, we have 3 remaining in the denominator. So that is equal to 1 over 5 cubed. So 5 times itself 3 times. And again, I'll show this using the way we used this yesterday, where if we're dividing and they have exponents, we can subtract them. So we leave the base of 5. And then you have 3 minus 6, so the numerator exponent minus the denominator exponent. And that is how we get 5 to the negative 3. And anytime you see that negative exponent, you should recognize that that's a red flag. So we want to put 1 over 5 cubed. So you want to change the exponent to a positive and then move it to the bottom. So these bottom ones, I think you get the expanded form demonstration. So again, we'll just do the division like we did yesterday, where we subtract them. So again, leave the base of a, and you take the exponent in the numerator, subtracted by the exponent in the denominator. So 3 minus 8, that is equal to a negative 5 raised to the negative 5th power. Again, you see that negative exponent, so that is a flag, 1 over a to the 5th power in the denominator. And then last one here again with exponents. So again, leave the like base of x, exponent in numerator subtracted by exponent in the denominator. and we get x raised to the 4 minus 10, which is x to the negative 6. And again, red flag with that negative, so 1 divided by x to the 6th power. Okay, so if there's any confusion on that, please pause the video and replay it just so you can see what it looks like in expanded form. But if not, again, we're just doing the subtraction we did with division, so the power in the numerator is subtracted by the power in the denominator. And then if you see a negative, make sure that you notice that red flag and then do 1 divided by whatever that coefficient or not coefficient, but whatever that variable is. If it's negative, bring it to the bottom and change the sign to positive. So going on, this is just a rule. So again, if we have 1 over a to the n, that means it was a risen to the negative nth power. So they just went the opposite way. So 1 over a to the nth power is equal to a to the negative n. Okay, so that's our negative power property. So now we are moving on to the quotient of powers property. But this is where we have more, we have more of the quotient of powers property, but this is where we see the zero, I believe it's called the zero power property. So again, the same process when we do expanded form is if we have 2 to the 4th power, that means it's 2 times itself 4 times. Divided by 2 to the 4th power again is 2 times itself 4 times. Simplification process like they showed, can cross out 2's where they're both on the numerator and denominator, and that is equal to 1. But now if we go back to doing the way of subtraction with our division of exponents, we can see that is 2, because that is a like base, we leave that, and then it is 4 minus 4, and that is why we get 2 to the 0 power. Like I said, anything that is risen to the 0 power is 1, and they had demonstrated that with expanded form. So same thing here, I'm not going to run through the expanded form because I feel like you guys can grasp this. But 6 minus 6, 5 risen to the 6 minus 6 is equal to 5 to the 0 power, which again is equal to 1. And you can do the same thing with exponents. So a is a like base, or exponent in the numerator subtracted by exponent in the denominator, 3 minus 3 is a to the 0, which is equal to 1. So again, really easy, but you're also going to see different ones where they try to trick you. So moving on to some examples. Oh, here's just the overall rule. So a to the 0 is equal to 1. Okay, so now we have some examples to run through. So we have 2 to the negative 3rd power. Again, if you see a negative power, it should be a red flag immediately. So that means that we have to do 1 divided by 2 to the 3rd power to get rid of that negative exponent. So that one is nice and easy. Moving on to b, we have 10 squared divided by 10 to the negative 2 power. So again, we can do our division rule of subtraction. So we have like bases of 10, so we can leave that. And then the numerator exponent is 2 subtracted by the denominator exponent, which is negative 2. As you can notice here, we have subtraction of a negative. So that means whenever there is a negative subtracted by a negative, that turns into a positive. So now we have 2 plus 2. So that is equal to 10 to the 4th power. If you're not certain how to, sometimes you get tripped up on subtraction of a negative, you can put it in your calculator, double check. But anytime you have subtraction of a negative, it becomes a plus sign. See here, this one can look a little tricky, but if you split it up into 2, how it is 3 to the negative 2 power times 5 to the 0 power, I like to look at this first. 5 risen to the 0 power. We talked about anything risen to the 0 power is 1. So then I just bring down 3 to the negative 2 power, and anything times 1, of course, is itself. So we're left with 3 to the negative 2 power. Again, that should be a red flag. We should not have a negative exponent. So that means that we have to do 1 divided by 3 squared. So bring that to the bottom and make that exponent positive. Okay, D, our last one, we have negative 3.75 risen to the 0 power. We know anything risen to 0, again, is 1. But I do want to point out that it is saying that anything in this parentheses is risen to the 0 power. So say if we had an x snuck in down here, that means that x is also being risen to the 0 power, so that is also all equal to 1. So you're going to see that also later on, so keep that in mind. Again, if I'm moving quick, you can pause at any point, or if you're feeling like you're grasping this, pause it and you can work on it. So now we got a few problems here. These are a little bit more challenging and requires our knowledge from the last couple days, but please keep your work organized. It will only help you more. So again, when doing these problems, we have multiplication. First, you want to look at your coefficients and split them. So we have 2 times 5, put those in parentheses. And then next we have a's here, like bases of a, so we have a squared times a, put those in parentheses. Then lastly, we also have the like bases of b's, so we have b to the negative third power times b. And we know with multiplication that we are adding our exponents, but first let's simplify our coefficients. We'll get 2 times 5, which is 10. Then we have a squared times a, so that means we keep a as our like base, and then we add our exponents, which is 2. There's a 1 here, but it is not always shown. So 2 plus 1, I'll write it out just in case if you're following along. And then lastly, we have b as our like base, so we have b, keep b as a like base, and we have negative 3 plus, again, a hidden 1 if you want to throw that in there. And then to simplify it all the way, we have 10 a 2 plus 1, so a cubed, and then b risen to the negative 3 plus 1 power, so negative 3 plus 1 would be b negative 2. Again, there should be a red flag because it is b to the negative 2, so we cannot leave it as that. We need to put that as in the denominator, so we'd have 10 still, a cubed because that is positive, but then we have b to the negative 2 power, so b squared would go in the denominator here. And that would be the solution. Okay, division. So we just did multiplication. Now we're going to do division. Again, to keep your work organized, you can use highlighters, colors, underlines, whatever you would like. But start with our coefficients. So we have 10 divided by 5. So again, I like to separate everything. So 10 over 5. Next, you can see that we have like bases of x's. We have x squared divided by x. And then we also have, oh, I lied, that is x to the negative third power. Okay, and then lastly, we have y's, y to the negative fourth power divided by y to the negative 1 power. Again, if you separate it, color code it, and keep it organized, it'll only help you more. So we can start here at 10 divided by 5. That is 2. X squared divided by x to the negative 3. Again, we know we leave x as our like base, and we do exponent in the numerator subtracted by the exponent in the denominator. So we get 2 minus negative 3. And then for y's, we get y as our like base, so we leave y. We have negative 4 subtracted by negative 1. Okay, so simplifying this, we still have a 2, then x squared, or x, and then 2 minus a negative 3. So that means, again, pointing this out again, so a subtraction of a negative, that means it's plus. So we get 2 plus 3, which is x to the fifth power. And then we get one more of those, so we get negative 4 minus a negative 1. So these become a plus, so negative 4 plus 1. We're still within negative, so we have negative 3. Again, if you have that negative, it is a red flag. So that means we need to leave everything that is positive in the numerator. So 2, its exponent is technically 1, so that is positive. And then x to the fifth, which is a positive exponent. And since y is negative exponent, we bring y and then bring the exponent with and make it positive. So we get 2x to the fifth, y cubed as our solution. Last one, your guys' favorite one. Like I talked about earlier, this is in parentheses. So it is saying everything in this parentheses is risen to the 0 power. And we know whatever is risen to the 0 power is equal to 1.